Hello everyone, this is me, Aurooj, your teacher from Management Sciences Department of University of South Asia. Today we are going to start a new topic that is based on multiplication rule. Firstly, we can just have a recap that what we have studied in previous lecture. In the previous lecture, it was all about conditional probability. Now, what was conditional probability? Simply, if you have the case when you have some sort of additional information, and just because of that additional information, your sample space reduces. And if your sample space reduces, the reduced sample space related probability is defined as conditional probability. And then comes the multiplication rule. We have already studied the formulas for conditional probability. For instance, if you have probability A given B, that means that is equal to probability A intersection B divided by probability B. If by using the multiplication rule हमें ये चीज़ पता है कि एक चीज़ अगर डिवाइड होती है वो दूसरी जगह जाके मल्टीप्लाई हो सकती है, so that is defined as your multiplication rule. So in short, multiplication rule is derived from your conditional probability where you have the formula and you can easily compute this multiplication rules questions. But the case is that if you have and in that particular question and some sort of restrictions or some sort of additional information, then we're supposed to use this multiplication rule. Moreover, we'll be discussing that what are independent and dependent events along with the help of some examples. So continuing with multiplication rule, that basically what is multiplication rule? Simply probability A intersection B, that is equal to what? Probability A given B into probability of B. Whatever is given under this condition, वो ही चीज as a multiple उसके साथ आ जाएगी. Then comes probability A intersection B, that is equal to probability B given A into probability A. Whatever is given under this condition, वो ही चीज as a multiple उसके साथ आ जाएगी. So this is defined as your multiplication rule. And when will you use this multiplication rule in your questions? For instance, now you have a question where it's stated as that box A contains 5 green and 7 red balls, whereas box B contains 3 green, 3 red, and 6 yellow balls. A box is selected at random and a ball is drawn at random from it. What is the probability that the ball drawn is green? Now what you have the case when you need to find the probability that the ball selected is green in color. If it's green in color, what possibilities can exist? The possibilities exist that it can be either from box A or it can be either from box B. So we have two possibilities of selecting the green ball. So just over here, what we'll be doing is, firstly we need to define the event. The first event can be defined as the ball selected is green in color. If it's green in color, you can simply define it as the G event. Then comes, we have two possibilities. The first possibility is that the ball selected can be either from box A. So you can define it as an event A, that box A is selected. Then comes event B. You can simply define it as the box B is selected. So by using the multiplication rule, you can easily compute all of these probabilities. And just the case, like probability of G is equal to what? That is equal to the probability that the ball selected is green in color and it came from box A. Plus, what's the second possibility? That it's green in color and it came from box B. So according to the multiplication rule, that is equal to what? जिस चीज की probability निकालनी होती है वो चीज हमेशा given से ऊपर आती है. And we're computing the probability that the selected ball is green in color. And what is in the given condition? That it came from box A. And whatever is given under this condition, as a multiple वो उसके साथ आ जाता है. So that is equal to probability G intersection A. Then comes probability G intersection B. That means it's green in color and it came from box B. So what will be the formula over here? That you need to compute the probability and you're finding the probability of what? That it's green in color and it can be from box B. whatever is given under this condition, same as a multiple उसके साथ वो चीज आ जाएगी. So we have two possibilities then, that if you have the case when you need to compute the probability that the ball drawn is green in color, it can be either from box A and it can be either from box B. So we have two possibilities over here. In short, we have used or we have utilized two multiplication rules in just one formula. So it can extend for whatever the case is. For instance, if you have 3 cases, 4 cases, simply you can extend this multiplication rule according to that particular question. So now, if you need to compute the probabilities, probability G given A. What does probability G given A means? That you need to compute the probability of the green ball that will be selected from box A. So total number of balls in box A are how many balls are there in box A? That is equal to what? 5 plus 7 is equal to total number of balls in box A. That means 12 balls. Out of these 12 balls, you have to select the probability that the ball selected is green in color. So how many green balls are selected? 5 green balls are selected. So 5 by 12 is the probability that the green ball is selected or is chosen from box A into probability of A. Now what does probability of A means? That the ball selected came from box A. So total number of boxes is equal to 2 and the box A is selected. What's that possibility? That is 1 by 2. So simply you'll get the probability of an event A as 1 by 2, and probability green given A means that the green ball is selected and it came from box A. So we have total 5 green balls out of these 12 balls from box A, plus probability of G given B. G given B means that you need to compute the probability of that if you have the case that the ball drawn is green in color and it came from box B. So how many balls do you have in box B? Simply add all of those balls. That means you have 3 green, 3 red and 6 yellow balls. So 3 plus 3 plus 6. That means you have a total of 12 balls in box B. Simply total number of sample points in box B is equal to 12 and green ball and the ball selected is green in color. How many favorable outcomes are there for this G event? That is 3. We have 3 green balls in box B. So simply you'll get the probability 3 by 12 in a case when you need to compute the probability that the ball selected is green in color and you have the condition that it was selected from box B. Then comes probability of an event B. Now what does it mean? It means that you need to compute the probabilities that total number of boxes is equal to 2 and you have to compute the probability that the ball selected came from box B. So what is the possibility for box B? That is equal to 1. That means 1 by 2 is the probability of an event B. And what was event B? Event B? It was defined as that the box B was selected. So right after simplification, you'll get the probability 1 by 3. Now this is the probability that the ball selected is green in color, and where we have 2 cases. The first case was that it can be either from box A, and the second case was that it can be either from box B. So we have 2 cases over here, and you can simply compute it by using this multiplication rule. Coming towards the next question, 3 boxes of the same appearance are given as follows. Box A contains 5 red and 7 white balls, whereas box B contains 4 red and 3 white balls. Box C contains 3 red and 4 white balls. A box is selected at random and a ball is drawn from the box. So what is the probability that the ball drawn is red in color? Now you have to compute the probability that the selected ball is red in color. That means we have how many possibilities over here? We have a total of 3 boxes. Three boxes, box A, box B, and box C. Now you have to compute the probability that the selected ball is red in color. So what will be the case? The first case can be that it's red in color, and it can be either from box A. Plus, what is the second case? That it can be red in color and it can be from box B. Plus, what is the third possibility? It can be red in color and it can be from box C. So probability of red is equal to probability R intersection A plus R intersection B plus R intersection C. Just wait a second, class. Okay, so you have to compute the probability of red ball. So the first possibility is that it's red in color and it can be from box A. So according to the multiplication rule, the event for which we are computing the probability, that is red in color, the R1, जिस चीज की probability निकालते हैं वो चीज हमेशा given से ऊपर आती है. And what was the additional information? The additional information was that it came from box A. And whatever is given under this condition, same वही चीज as a multiple उसके साथ आ जाएगी. That means probability of box A plus probability R intersection B. Now what does R intersection B means? That you have to compute the probability that the ball selected is red in color, and what was the condition? That it came from box B. And whatever the condition is or whatever the additional information is, वही as a चीज उसके multiple के साथ आ जाएगी. That means probability of an event B. Then comes probability R intersection C. What does R intersection C means? That you have to compute the probability that the selected ball is red in color and it came from box C. And whatever was given under this condition, same वही चीज as a multiple उसके साथ आ जाती है. So now you need to compute the probability that the ball selected is red in color and it came from box A. So total number of balls in box A, that is equal to what? That is equal to 12, because we have a total of 5 red and 7 white balls in box A. So 5 plus 7 is equal to 12. Total 12 balls are there in box A, and out of these 12 balls you have to select that the ball selected is red in color. And how many red balls do you have in box A? We have a total of 5 red balls in box A. So 5 by 12 is the probability of R given A. Then comes probability of an event A. Now what does probability of an event A means? Now we have a total number of boxes, that is equal to 3, and you need to compute the probability of an event A. Event A means box A, that is equal to 1, because A की box है आपके पास. So 1 by 3 is the probability of an event A. Then comes plus probability R given B into probability of B. Now what does R given B means? That we need to compute the probability of the red ball, and we have the condition that it was selected from box B. So total number of balls in box B is equal to what? We have a total of 7 balls in box B. That is, we have 4 red and 3 white balls. So 4 plus 3 is equal to 7. 7 balls are there in box B. So that will come in the denominator term. And then you need to compute the probability that the selected ball is red in color. So we have how many red balls? We have total 4 red balls in box B. So 4 by 7 is the probability of R given B. Then comes probability of B. What does probability of B means? That means box B is selected. What is the possibility that the box B is selected? So total number of boxes, that is equal to 3, and the box B will be selected. That means we have only one favorable outcome in an event B. So 1 by 3 is the probability of an event B. Plus probability R given C. Now what does R given C means? Now you need to compute the probability that the ball selected is red in color, and we have the condition that it came from box C. So total number of balls in box C is equal to what? That is equal to 3 plus 4, that is equal to 7. We have a total of 7 balls. Now out of these 7 balls, you have to compute that the ball selected is red in color. So how many red balls do you have? You have 3 red balls in box C. So 3 by 7 is probability of R given C. Multiply by probability of C. Now what does probability of C means? That means it was selected from box C. So total number of boxes is equal to 3 and the number of favorable outcomes in an event C is equal to 1. So 1 by 3 is the probability of an event C. So right after simplification, you'll get the answer 0.4722. So 47% chances are there that the ball drawn will be red in color. So now this was the case where you have used 3 multiplication rule in just one part. So you can extend this rule according to your requirements, whatever the case is. If it's extended like you have 10 boxes and you need to find the probability that the ball selected is red in color, so it can exceed to whatever the case is. Now you have B part. Now what it is stated as, if the ball drawn is red, what is the probability that it came from box A? Now you have to find the probability for an event A that the box A is selected. And you have the condition. Now what is the condition? If the ball drawn is red. Now we have a condition. If the ball drawn is red, what is the probability that it came from box A? जिस चीज की probability मांगी जाती है वो चीज हमेशा given से ऊपर ही आती है. Now what is it equal to? It's equal to probability A intersection R or R intersection A, that makes no difference, divided by whatever is given under this condition, that is R, that will be in your denominator term, that is probability of an event R. So probability of an event R is equal to what? That is equal to 0.4722. So 0.4722 will be in your denominator term, and you have to find the probability that the ball selected is red in color and it came from box A. So this case is just the same as this one. That means ये जो आपका part है इसमें और उसमें कोई difference नहीं है, because A intersection R or R intersection A makes no difference. So you have the case over here that 5 by 12 into 1 by 3 is equal to probability R given A into probability of A. And same is the case over here. That means A intersection R, that is equal to 5 by 12 into 1 by 3. So simply by taking the ratio of both of these probabilities, you'll get the answer 0.294. So 29.4% chances are there that the ball selected is red in color and it came from box A. So you can simply interpret the results for whatever the case is, and you can extend it as well by using multiple multiplication rules into the one or any sort of probability based question. Now coming towards the next topic, that is based on independent and dependent events. Now suppose you have two events A and B in the same sample space, and they are said to be independent if the probability that one event occurs is not affected by whether the other event has or has not occurred. That means two events are said to be independent, that at once if another event occurs, then it's not affected by whether the other event has or has not occurred. Because probability A given B means that an event B is already occurred, and you need to find the compute the probability for an event A. And what does probability B given A means? B given A means that you have an event A, it's already occurred, and you have to find the probability that an event B event B exists. So if probability B given A means that an event A is already occurred, and you have to compute the probability for an event B. So if you have these cases, you need to determine whether they are independent or not. Whether if an event B has occurred, any effect or any sort of change has occurred in A or not. So for that case, we need to compute whether events are independent or whether they are dependent. So for independent and dependent events, probability A given B means that an event B has already occurred, and just because of that event, you need to find the probability of an event A. So in case of independent events, that will be equal to probability of an event A. That means B के अकर करने से A को कोई फर्क ना पड़ता हो. That is equal to probability of an event A. Then comes probability B given A. Probability B given A means an event A has already occurred and you have to compute the probability for an event B. That is equal to probability of B. That means event A has already occurred and whatever the event has occurred, no change occurs in that particular event. That means for an event B. A के अकर करने से B को कोई फर्क ना पड़ता हो, then we are supposed to say that events are independent. If inequality is held or is held between both of these sides, that means probability B given A is not equal to probability B, or probability A given B is not equal to probability A, so that means events are dependent. They are not independent. Then you have the case probability A intersection B is equal to probability A multiplied by probability B. If equality holds between both of these sides, we'll just say that the events are independent. So this was the concept related to independent and dependent events. If you were asked in the question that are they independent or whether they are dependent or not, then simply you need to determine whether the left hand side is equal to the right hand side, or if inequality is held between both of these sides, then you simply say that the events are dependent. Okay. So coming towards the next question, two events A and B are such that probability of an event A is equal to 1 by 4, probability of an event A given B is equal to 1 by 2, and probability B given A is equal to 2 by 3. Are A and B independent events? Now you have to determine whether the both events are independent or not. So simply you can see that probability A given B. In order to determine whether they are independent or not, we have studied the rule that if probability of A given B is equal to probability of an event A, then we're supposed to say that the events are independent. You can see over here that probability A given B is equal to 1 by 2 and probability of an event A is equal to 1 by 4. So 1 by 2 is not equal to 1 by 4. That means events are not independent, they are dependent. Just like this one. You had the case when you need to determine whether A and B are independent. So according to the given statement, probability A given B is equal to 1 by 2, probability of an event A is equal to 1 by 4, and probability A given B is not equal to probability of an event A. That means 1 by 2 is not equal to 1 by 4. So events are not independent. Coming towards the B part, are A and B mutually exclusive events? Now you need to determine whether they are mutually exclusive or not. So when you need to determine whether the events are mutually exclusive or not, we have the case that probability A intersection B is equal to 0. If probability A intersection B is equal to 0, then we can say that the events are mutually exclusive. Because what was the concept of mutually exclusive? Simply, suppose you have two events, events A and B, and nothing is common in between both of these events, then we just say that the events are mutually exclusive. If something common occurs between both of these events, then we'll just say that the events are not mutually exclusive. So, according to the given question, we have probability A given B that is equal to 1 by 2. So simply, what you can do is, we know that okay, We know that probability A intersection B should be what? It should be equal to 0 when you have the case um, of mutually exclusive events. So here you have probability A given B that is equal to what? That is equal to probability A intersection B divided by probability of an event B. Whereas according to the given question, we have probability A given B is equal to 1 by 2. So that means we have the concept of mutually exclusive events, that probability A intersection B is equal to 0 when events are mutually exclusive. But if probability A intersection B is equal to 0, that means अगर आपके पास ये वाला portion 0 होता, then it was quite obvious that probability A given B was also equal to 0. But over here, probability A given B is equal to 1 by 2. That means probability A intersection B is not equal to 0. Just because of that, probability A given B is equal to 1 by 2. So if probability A intersection B is not equal to 0, that means events are not mutually exclusive. Because for mutually exclusive events, we need to determine, or we need to know that nothing should be common in between both the events, that is event A and event B. So in this case, events are not mutually exclusive. Then comes find probability A intersection B and probability of an event B. Probability A intersection B means what? Now, according to the given statement, probability A intersection B can be computed by, if you have this formula, probability A given B, you can easily compute probability A intersection B by simply multiplying probability B on the other hand, that is probability A given B multiplied by probability B. But you can simply see that we don't have probability of an event B in the given question. We have only probability of an event A, probability of an event A given B, and probability of an event B given A. So according to the given data, you have to compute probability A intersection B. If you'll use the case that probability B given A, now probability B given A is equal to what? That is equal to probability A intersection B divided by probability of an event A. Okay, probability of an event A. So we have the case probability B given A, that is equal to 2 by 3, and probability of an event A, that is equal to 1 by 4. So simply, can we compute probability A intersection B from this case when you can simply multiply probability of an event A on the other hand? That means probability B given A multiplied by probability of an event A is equal to probability A intersection B. So by using this formula, that is probability A intersection B is equal to probability of an event A, that was equal to 1 by 4. Probability B given A, that was equal to 2 by 3. And you'll just multiply both of these probabilities and you'll get the answer 1 by 6. So this was the probability of event A intersection B. Then comes, you have to compute the probability of an event B. So by using this formula, now you have computed probability A intersection B. What was probability A intersection B? It was equal to 1 by 6, this one. And you have the case of probability A given B that was equal to 1 by 2. So you have both of these probabilities. That means probability A given B is equal to 1 by 2, probability A intersection B that was equal to 1 by 6, and right after substitution you'll get the answer for probability B. So this is the case that probability B is equal to 1 by 6 divided by 1 by 2. So you'll get the probability 1 by 3 of the case when you need to find the probability of a specific event, that is an event B. Coming towards the next question, let A be the event that a family has children of both sexes, and B be the event that a family has at most one boy. If a family is known to have 3 children, or if a family is known to have 4 children, are they independent or not? So simply they have defined the events as an event A and as an event B. Now what is an event A? Event A is defined that a family has children of both sexes. That means it can be either a baby girl or it can be either a baby boy. Then comes B with the event that a family has at most one boy. At most means maximum one boy and minimum no boy. If a family is known to have 3 children, determine whether the events are independent or not. So simply what you can do in this question. Okay. So you have the case if a family is known to have 3 children. So the first case it can be either a baby boy or it can be either a baby girl. Then comes the second one. Second birth पे either a baby boy can occur, either a baby girl can occur. Same goes for this one. If at first girl appears, then for the second birth, either the baby boy can occur or either a baby girl can occur. Then comes if for the third baby, it can be again the 2 genders, either baby girl or a baby boy. Same goes for this one. If at first boy occurs, then girl occurs, then at third, either a boy can occur or a girl can occur. Similarly, at first if girl occurs, then boy occurs, then at third, either a girl can occur or a boy can occur. Moreover, if at first girl occurs, then again girl occurs, then at third, either a boy can take place or either a girl can occur. So what will be the sample space? Simply okay. What will be the sample space? Now you'll have the case that 3 of them are boys. The first 2 are boys, then a girl will occur. Or if you have the case that first is boy, then come girl, then again boy. First is boy, then comes girl, again a girl. Then comes girl, boy, girl, girl, boy, boy, girl, girl, boy, girl, girl, girl. So this is a sample space if you have the case that if a family has 3 children, simply boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, girl, girl, boy, boy, girl, girl, boy, girl, girl, girl. So this is a sample space if a family has 3 children. Now you have to determine that whether the events are independent or not. So simply an event A can be defined as, what is an event A? Event A is that a family has children of both sexes. Both sexes means that boy and girl both should occur between these favorable outcomes. So except this one and except this one, all of these outcomes have both of these genders. So event A can be defined as boy boy girl, boy girl boy, boy girl girl, girl boy girl, girl boy boy, girl girl boy. This is an event A. Then comes an event B. What is an event B? Event B is defined as uh, a family has at most one boy. At most one boy means maximum one boy. Okay, maximum one boy and minimum no boy. So all of these outcomes have minimum one boy, except the one where all of the three children will be girls. So we have these 7 sample points that both genders will be present, or both girls and boys will be in that favorable outcome. So this is an event B. Now you need to determine whether the events are independent or not. So in order to determine whether the events are independent or not, what you can do is, we have the rule that probability A intersection B is equal to what? That is equal to the product of probability of an event A multiply by probability of an event B. Now what is probability of an event A? Probability of an event A is equal to favorable outcomes in an event A, that is equal to 6, and total number of sample points, that is equal to 8, multiply by probability of an event B, that is how many sample points are there? There are a total of 6 sample points. When you have at most one boy, at most one boy means maximum one, at most maximum one boy. So that means how many sample points will be there in this case? We'll just have the case where this will not occur in this case. Moreover, not either this one, not either this one. So only 3 sample points are there that maximum one boy will occur. So 3 by 8. If it's equal to probability A intersection B means the common in between both of these events, then we'll say that the events are independent. But if inequality is held between both of these events, we'll just say that the events are dependent. Same goes for this one. If we have 4 children means that this tree diagram will be extended for 2 more events. And if it's extended for 2 more events, then it will be the case like boy, boy, boy. Then comes, it can be either again a boy or a girl. That means boy, 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 girl, boy, boy, girl, boy, 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 girl, girl. Up till so on, girl, girl, boy, girl, 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 boy, girl, 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 boy, girl, 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 girl. Up till so on. So same, you can compute it for 4 children as well. Simply, what is probability of an event A? You can define it as for that particular event. Then comes probability for that event A B, that is your 3 by 8, and you can simply multiply both of these terms and you can determine whether the left hand side is equal to right hand side. If left hand side is equal to right hand side, then we can easily determine that whether the events are independent or not. Okay, so we can just sum up that what we have studied in today's lecture. Firstly, we have studied was all about conditional probability. Simply, if an event A or B has already occurred and you need to compute the probability for another event, then it's defined as conditional probability. Or you can simply say that just because of some sort of additional information, your sample space reduces, and probabilities associated with the reduced sample space is defined as conditional probability. And this multiplication rule was derived by using conditional probability formula, and the independence and dependence of the events can be computed by using probability A intersection B. If it's equal to probability A multiplied by probability B, then we'll say that the events are independent. If inequality is held in between both of these sides, left hand side and right hand side, then we'll say that events are dependent. Or you have the alternative way as well, that if probability A given B is equal to probability A, that means just because of an event B, no change occurs for the event A, then we'll say that the events are independent. And if probability B given A is equal to probability B, that means an event A is already occurred and you have to compute the probability of an event B. But because of that event, that is an event A, no change can occur for that event B. So we'll just say that the events are independent. And if inequality is held in between both of these sides, we'll say that the events are independent. Inequality, then they are said as dependent. And if equality is held in between both of these sides, we'll just say that the events are independent. So this was all about today's lecture. I hope you've understood whatever was taught in today's lecture. But still, if you'll find any difficulty, you may ask me via email, or you can just comment below the given video. Thank you so very much. Allah Hafiz.